to start, and we will start soon. Let's wait for people to join. Hi Shitra Mohan, I just start. Wait a minute. I think the screen is visible. Okay, so let's start with upcoming lectures, and I will start with perturbation methods. Like, so this is your tutorial for, okay, yeah. So what are perturbation methods? So we have to solve the PDEs at ultimately, right? Our goal is to solve the partial differential equation in the last. But what we gonna do today is just to describe like how to find out the solutions, right? Using power series expansion. So if you have an equation like this, how will you solve it, right? It's not very easy to solve. So what to do, like if your epsilon is 0, then it's just straightforward, right? U equal 1 is solution of first. So that's very straightforward. And one thing that I want to say is if your epsilon is greater than 0, then what you will gonna do in that case? So you reconsider your equation and you write u as some function like sum of, I just write like this, n equals 0 to infinity. So if I write u as something like this, so what is called this? This is basically the expressing u as sum of some other functions u0 u1 up to un with coefficients epsilon to the power n. So this is just one type of expansion, but you can study more types of expansion as you proceed. So this one is the first one that sir has already see if you have seen the lecture. So I'm just summarizing and pointing out the important things that you need to remember. Yeah, so what I'm just doing is I just substitute this expansion over here. So you have to make sure that you can write u as something like this. So this is like u is in some space and that space is complete. If you go mathematically, I just don't go with that thing. So if I write u like this, then it is 1 plus epsilon u1 plus, so if u naught is basically 1, so here u naught is 1. So and epsilon square u2 and so on, right? So if you substitute it over there, then you just get u1 plus epsilon square u2 plus epsilon cube u3 and so on. And another side you do have 1 plus epsilon, 1 plus epsilon u1 plus epsilon square u2 and so on up to square, oh sorry, cube, because here it is. Here it's a cube, right? Okay. So you cancel out 1 on both sides. Epsilon u1 is, so I just take the common terms, epsilon u1 minus 1, epsilon square u2 minus 3 times u1, plus, and so on. Okay. So what does it give? It gives u1 equals to 1, u2 equals to 3 times u1, and so on, right? So u2, if u1 is 1, u2 is 3, u4, you can try to calculate what is that is u2, what is u3, which is 12, and so on. So ultimately, you are able to find out which coefficients are coming, right? U1, U2, and so on. So U is just expanding. You can express U as the sum of these functions, um, and try to find out these values of U1, U2, and so on. So what is final U? U is just 1 plus epsilon plus 3 epsilon square plus 12 epsilon cube, and so on. So that is your final U. Okay, is it easier to understand? I think so. Okay. Another thing you can try to find out, so I will just give you some time to find out the solutions of this equation. So if I give you this one, wait, I just write. So find solutions of the equation d2u by dt2 plus u is equal to epsilon 1 minus u square du over dt using the same method. So that's very easy. You just try it and see what's going on. Okay, so how to find out the solution in this case? Let's proceed. Okay, so you have to do the same thing. So I just take u equals to summation u naught and uh, sorry, it is un and epsilon to the power n, where n is going from 0 to infinity. So you just substitute it over here. Okay, so what is that? So if epsilon is 0, then your differential equation is just this one, which is minus u. And you can easily solve it where u is equal to a cos times t plus phi, something like this. If epsilon is positive, then your equation will be like this. Okay. Okay, so how do you expand u? The same thing. So I just write u t epsilon same as u naught t plus epsilon u1 t plus epsilon square u2 t and so on. Okay. And there is, if you substitute it over there, then you just get d2 u naught divided by dt2 plus u naught plus epsilon times d2 u1 divided by dt square plus u1 plus epsilon square d2 ut divided by dt square plus u2 and so on equals to epsilon times 1 minus u naught plus epsilon u1 plus epsilon square u2 plus and so on. And you do have du naught over du dt, du1 over dt and so on. Okay, so that will give you something like this. And if you compare both terms on the both sides, then you will get d2 u naught divided by dt2 plus u naught equals to 0, which implies u naught is a cos t plus phi, something like this. And similarly, you do compare all the things to find u1, u2, u3 and so on. Okay, so you can do that, right? Okay, we can try another method which finds, so here is that, I just tried it. Okay, what is this? Okay, so there is another question which says, I just write using blue. So if it's your equation dx square plus dy over dx plus xy equals to 0. So you have to find the solution use a power series using method of Frobenius. Y equals to summation am over mu plus m equals 0 to infinity. Then you obtain approximate series expansion. Means try to find out these coefficients am m equals 0 to infinity. We will try this now and let's see. 5 minutes. Okay, let's try this now. How would you approach it? Okay, so what is y prime x in this case? Can you tell me? Okay, so that is m equals 0 to infinity. And so what is this? Mu plus m and am. So you just differentiate it. Mu plus m minus 1. Okay. And similarly, you have y double prime x, which is summation m equals 0 to infinity mu plus m minus 1 am x to the power mu plus m minus 2. Okay, so I just take another page, my plain page. Okay, and then it will give you, so we just try to substitute in the following coordinate differential equation in the first. So what will give, so I just write it again here. Can I copy it? Let me, oh, why does it look like this? There should be some selection way to select. Draw stroke, what does it mean? Select text. Okay, does it select? Cannot select the text. Select rectangle, select region. So I just select this region. Why does this not fit over here? No, okay, yeah. So I just copy it and paste it here. Okay, so this is the differential equation that we are working at, and I just try to substitute the values now. So here, if I do, so what is y double prime x? So just substitute here and there. So what is this? So this is just this one. So x times mu plus m minus 1 am x to the power mu plus m minus 2. So I just substitute this value of x over there. So that would give you minus 1, right? So that is from summation m equals 0 to infinity. So that's a homework exercise by, so I'm just doing it here so you know better understand. Okay, so what is summation m equals 0 to infinity? And y prime x is this one, mu plus m mu plus m minus 1 plus x times y. So that's just simple. Um, so mu plus m is your x, y is just this am x to the power mu plus m plus 1 summation m equals 0 to infinity, and that will be 0. Okay, so you substitute this equation and into this. So what you're gonna do is you try to compare both sides. So what is right side? That is not the same. Okay, that's the same. Okay, you try to compare the right side. So starting from m equals 0 and going till m equal to infinity. So we have to collect the powers of m mu to the x to the power mu plus m. Yeah. So how would you do that? Okay, so let me see. Okay. So here you have x to the power mu plus m minus 1, and here you do have the same thing. And here you do have x to the power mu plus m plus 1. So you can take both these things together, mu plus plus m minus 1 plus 1. So it's basically, if you combine these two things together, then you get this mu plus m if you take out common, and mu plus m square. And other thing is x to the power mu plus m minus 1 plus summation m equals 0 to infinity am x to the power mu plus m plus 1 equals to 0. Yeah. So you got these two equations in this case, and you have to see like, so if you put m equals to 0, then you get x to the power mu minus 1, and here x to the power mu plus 1. So you need to kind of shift so that it makes something like this. So you have to replace m by something which gives you the same indices of x over there. So how do you do that? So replace m by m plus 2. Replace, okay, take m is equal to, in this one, in first one, you just take m is equal to q plus 2 something, sorry, n plus 2. Then if you take m equals to n plus 2, then n is starting from minus 2, right? When m is 0, then n is minus 2, of course. Okay. Or if you take here, then it just start from m equals 0, so mu plus 1. So if you take n plus 2, then it will cancel out, and mu plus, okay. So overall, it will be n equals to minus 2 to infinity mu plus m is n plus 2, so mu plus n plus 2 square a n plus 2 x to the power mu plus n plus 1. So that will give you like this thing, plus summation m equals 0 to infinity am x to the power mu plus m plus 1. Okay. But here the same things are not there, so we need to fix and in this way. So what is the coefficient of x to the, if n is minus 2 and here m is 0, right? So what is the coefficient of x? X to the power mu plus 1. What is that? So if n is minus 2, then this thing is 0, so mu square a naught plus, and here you have a0. So this implies a naught 1 plus mu square is 0. This implies a naught is 0. Okay. And similarly, you have the coefficient of, if you put n equals to minus 1, then you do have x to the power mu. Okay. And in that case, you do have a1, and you do have mu plus 1 square. So mu plus 1 square a1. So here a naught is coming only by this, and x to the power mu plus, and here you have so when m is 1, then it is a1, and in that case it's okay. So why is that minus 1, then x to the power mu, but x to the power mu is not coming here, here it's coming, right? Okay. So if, yeah, you just put it again to be 0, then it implies a1 is 0. So a naught is 0, a1 is 0, but here if you put the same thing, a1 and x to the power mu plus 1, then it also gives a1 equals to 0. Then you will find out, like, if you find out what is a2, a3 and so on until it comes. So you need to look at it, like how do you find the coefficients. Okay, so that's the basic thing that you need to compute. You need to fix, you need to put the values of the power series in the equation, and then you need to find out the values of a naught, a1, a2 and so on. So that's it. Okay, so there is another type of expansion that I'm going to show you. Okay, another expansion. So if you have the power series like this, if you have a differential equation like this, and y is given by summation m equal 1 to infinity am divided by x to the power m, then you have to find out the solution, right? So you substitute it there again. So what do you get? Summation m equal 1 to infinity minus am power minus m minus 1 plus summation m equal 2 to infinity am to the power m minus m plus a1 minus 1 x to the power minus 1 equals to 0. Okay, so a1 minus 1 x to the power minus 1 plus summation m equal 1 to infinity am plus 1 minus mam x to the power m minus 1. Yeah, so here it will be 0. This implies this. And comparing both sides gives you a1 equals to 1, a3 equals to 2 factorial, a4 equals to 3 factorial, and so on. An equals to n minus 1 factorial. And if u is equal to, okay, so that will give you this thing. Okay, all right, so that's very easy. So you've totally find out what is am in this case. That is very straightforward. Sometimes you end up with something like, okay, I'll just show you one thing. Okay, that's being told. So yeah, that's about the expansions and all that. You can always put it up and you can always find out the values of the coefficients. I think it's clear to you, right? So just have a look at it, and if you have any questions, let me know. And we will go with more, we will go with what are, what, okay, what is dynamical system? Okay, now what is not, it. Okay, we will discuss the ODs, phase plane analysis, and the stability of fixed points. Yeah, we will discuss that now after that. Okay, just have a look, and if you have any questions, just let me know for now. Okay, let's discuss a equation from predator prey model. Let's do that. Okay, so if you have predator prey model, so the equations are this: ax minus bxy divided by dt is something like this. And you try to find out, okay, what does this mean? Xt is your prey population, yt is your predator population, a is prey growth rate, b is predation rate, c is predator death rate, d is predator growth rate. And we solve this equation. So what is the equilibrium like? So we need to find fixed points or equilibrium. So what's that? So you put it, this is something like this fxy, and this is something gxy. So you put fxy equals to 0 and gxy is equal to 0 to solve. Okay, so what does this give? This implies x is 0 and y is 0 is 1 point, and another one c by d and a by b is 1 point. Okay, so that is two fixed points. Now you consider a matrix. So fixed points are like where your solution will approach. Okay, a matrix is basically a Jacobian matrix, so which is given by jxy same as a minus by minus bx dy minus c plus dx. How this came? So you just do del f over del x, del f over del y, del g over del x, del g over del y. Okay. So what is del f over del x? That is a minus by. Del f over del y, it is minus bx, and so on. Okay. So that will give you this. Eigenvalues are purely imaginary. So if you find out the eigenvalues of j, how do you find the eigenvalues of j? So to find out, you just calculate determinant of j minus lambda I to be equals to 0. So what does this imply? It implies that lambdas, so yeah, so this implies that, okay, so at 0 0 j is what? What is at 0 0? J is basically a minus a0 and 0 minus c. So eigenvalues are the diagonal elements. Okay, so eigenvalues a and minus c. Okay, at c by d and a by b, j is 0 minus bc by d, ad by b. You can find that. And in this case, the eigenvalues are, so you just solve determinant of L. So minus lambda determinant of this ad by b and minus bc over d equals to 0. So that is lambda square minus ac equals to 0. So lambda is basically, if you go in this way, so it is plus plus minus iota under root AC. So that are imaginary eigenvalues. So in this case, you do have, so this is, so if all both the eigenvalues are imaginary, then fixed point is center. So just remember this. And for 0, 0 eigenvalues are A minus C. In that case, one is negative, one is positive. Then in that case, we do have a saddle point. So I'm just naming them. I'm not showing like how does they look like, but you can find it in your textbooks and all. Okay, so that's the thing, and depends on like which type of problem you are working on. Okay, so for example, if I give you the center, like, so if you have A is equal to 1, B is equal to 0.1, C is equal to 1.5, D is equal to 0.075, then you do have a center like this and this and this. So center is like this. So your center point is A by B and C by D. So A by B and C by D, which is basically the value 10 and 20. Okay. Sorry, it is, I think, 20 or 10. What is this? Y is A by B, X is C by D. Okay, so we do have, what is this? Oh yeah, so C by D, A by B. C by D is first, C by D and A by B, which is 20, 10. So this point is 20, 10 actually. And you do have these circles over there because it is the center, okay, that we have shown. So the trajectories will revolve around like this. So this is prey X and this is what we did. So you can try as many examples like this and try to find out what are the center uh, and saddle points, stable points, stable fixed points, stable unstable nodes like this. So just try to find out using some examples from maths textbooks that you can find out. Yeah, so just I want to mention this and all. If you have any doubts, you can ask now. So just a brief overview. You have to practice questions based on that, of course. Yeah. Chitra Mohan, you want to ask something? Okay, so if you have no questions now, so I just stopping. Thank you very much for your time and see you next week where we will discuss some more models. So maths part is done almost and we will discuss more on modeling part from next week.